Hi, my name is my name is Jesslyn Alexis. I'm from 10-2, and yeah, that's all you need to know about me. Okay, first of all, I need to make it clear that I was forced to make this video. So if you don't have any interest in watching this video, then get out. Don't even watch the video. Jeez. Hi. So what is this video? I'm gonna do an experiment. I'm gonna have to scroll a little bit because I don't remember. Who remembers these things? We're gonna do an experiment on the effect of temperature on the rate of dissolvement of sugar in water. That is a mouthful. But anyways, simple, what do you call it? Layman's term. The layman's term for this experiment is how fast will sugar dissolve in water when it's using different temperatures of water. Because hot water and cold water, they might have a different rate of dissolvement. So how fast it dissolves in cold water compared to how fast it's gonna dissolve in hot water. So the materials of this experiment, wonderful. We have a plastic tablespoon. I'm gonna explain about that later. It's just a tablespoon and it's plastic. A glass cup, approximately 200 milliliters. Yeah, we're just using the same glass for the whole experiment for controlled variable purposes. And we have this 200 milliliters measuring cup that already has water in it. I'm gonna explain that later too. The second last equipment is a metal teaspoon. It's just a regular metal teaspoon. And the last thing that we need is a stopwatch. Since I am a normal person and I don't have a digital stopwatch at home, because who even? I'm using my phone stopwatch. Yeah, that's it. For the materials, for this trial only, we're just gonna discuss about this trial. We have 100 milliliters of regular temperature water. So it's 28 degrees Celsius, approximately. And we have sugar. So this is white granulated sugar. You don't want to use those powdered sugar because they're less accessible. Why did I choose white granulated sugar? Because they're the most accessible for all households. Most households have regular white sugar. And for consistency purposes, we're also going to use the same sugar throughout the experiment. So how much do we need is about 1 teaspoon. So let's just start the experiment, I guess. So this bowl, I have to say, it's not included. This is just to make my life easier. Because the slogan of this experiment is easy, simple, yeah, and low effort. Because why would you put a lot of effort when you could put little effort? It just makes sense. That is one of the reasons why I chose this experiment in the first place, because it's simple. It's water and sugar. Who doesn't have water and sugar? Well, me, because I had to look for sugar. It was a tough time when I didn't have sugar in my house. But I finally got sugar, and so we're doing this. So the first thing in the method is scooping the sugar. Okay, scooping the sugar. So as you can see, this is your regular teaspoon. It's heaping. You do not want this. This is wrong. You want it level. You want level, like a civil person. You want a leveled, shake it out a little. A leveled teaspoon of sugar. So you might not be able to spot the difference, much of it at least. But this is more leveled, and this is the amount that I've been using throughout the experiment. So we're just gonna put this aside for now on, let it set. And now, in the actual experiment, you're gonna have pour the water into the measuring cup. But since this is regular room temperature water, that doesn't change in temperature, in room temperature. So we're just gonna, I've measured this out beforehand, and this is 100 milliliters. Yeah, perfectly 100 milliliters. Yeah, there. Yeah, we're just gonna put the sugar right into the cup. So yeah, there you go, sugar in the glass cup. And now we need to set our stopwatch. So this will be very, very fast paced. You need a certain amount of skills to be able to do this experiment, because it needs certain type of wit. with. Let's just put that in first to make it quicker. Now we're gonna pour the water. Wait, as soon as the sugar hits the water, we're gonna start the stopwatch, and then we're gonna start stirring. So the stirring is gonna be at 2 stirs per second. Yeah, so we're just gonna put the stopwatch right here. So wait, and then you start stirring for like 2 stirs per second. So I'm just like keeping up with the stopwatch right now, so it's 2 stirs per second. So what are we looking for? We are looking for the sugar completely dissolving in the water, so there's no more sugar granules left in this water. So as you can see, I'm doing it in a circular motion, clockwise, because yeah, that's for consistency purposes. I mean, why not? So a little bit spilled, but that doesn't really matter actually. I bet you couldn't see that anyways. Like nothing spilled. It's all good. So we're passing the 50-second point now, and as you may see or not see, there's still some sugar granules left. So we're just gonna keep stirring until there isn't any left. Yeah, you need a lot of patience. Wait, it's almost over. Okay. Okay. So finally, everything dissolved. Yeah, whatever. Everything dissolved 1 minute 10 seconds after. So as you can see, like everything dissolved already. So that's basically how you do the experiment. And then now we're gonna put this number, which is 1 minute 10 seconds, into the table that we have made. And that's it. That's literally it. Like, we just do that all over again 25 times, basically. If you run out of ideas for experiments to do at your home during quarantine, I would not recommend this because it's boring. Like, do some other fun stuff. But yeah, if you really need to, then like, sure, you could, I guess. Yeah. We have to, anyways, I'm probably gonna come back in a few days to discuss the results of the experiment and like the explanation in chemistry language.
Hi, I'm back. So anyways, now after forgetting all about this thing and panicking to edit this at the last minute, which is already way past deadline anyways, but I'm here to discuss the sciencey parts of this experiment with you. So the hypothesis, let's start there. The first thing in my hypothesis, wait, that's not even it. My hypothesis is that the hotter the water, the easier it is for sugar, not salt, sugar to dissolve in it. So that ended up to be true because according to the data, that it was indeed true. Yeah. So here's the graph to show it. Let me just look it up for you first. You can kind of see it, so it's like I have to tilt it. Anyways, don't mind my Barbie. This is hot water, so this the x-axis is the temperature and the y-axis is the time it takes. So as you can see, the hotter the water, which is the hottest water, it had 22.81 seconds, while the coldest water, that is the closest to 0 on the x-axis, took the longest time to actually dissolve. So the whole graph shows that the hypothesis was indeed correct. So why did I pick that hypothesis in the first place? Well, according to some theories from the internet, hot water has more energy in it compared to cold water because, well, it's hot, so it has heat energy. And it takes heat energy, well, not necessarily heat energy, but energy to change the state of matter from solid to liquid. And I also thought that the closer it is to the melting point of the solid, the easier it will dissolve, which is why at the end it dissolved easier in the hot water because it's closer to the melting point of sugar, which is 186 degrees Celsius. And another part is maybe just logic, because you know how you have syrup, which simple syrup is 1 part sugar, 1 part water, and how you actually make that fastest is by doing it over heat. However, there are other methods that don't use heat, and usually it takes longer. So from that sort of example from real life, I took the hypothesis that the hotter the water, the faster it will dissolve. So point is, it ended up being correct. However, it was slightly different in the sense that the negative correlation between the temperature of water and the time it takes for sugar to dissolve was not linear but exponential. And why did this happen? Well, because it deals with surface areas. Dissolving has something to do with surface area. So for example, this is 1 granule of sugar. What is in touch with the water around it, the solute, is the outer layer. So since the outer layer dissolves and dissolves and dissolves, it ends up being smaller and smaller and smaller, and therefore less surface area is in touch with water. And that decrease from that size to maybe like that size is exponential, and which is why the decrease was not linear but exponential. So that is all the explanation I have for you today.
Bye.